Hello there. Welcome to Moody Institute of Science. Say, do you like mystery stories? Well, we have one for you. In the tradition of all good mysteries, it's complete with a haunted house and ghosts out of the past. A science lab seems a strange place to look for ghosts, doesn't it? But our story is true. Before we're finished, I think you'll agree that truth is stranger than the strangest fiction. The mystery is time. The haunted house is space. In our true story, the ghosts travel at the speed of light and they come straight out of the past. Your past. Yes, time is a mysterious thing. Have you ever tried to define time? The harder you search for a definition, the more elusive it becomes. We're going to explore the mystery of time in the laboratory. Before we find the ghosts, we'll have to sort through some facts, but we'll find them, for they're very real. Hello, Pete. How are things going?
Fine, Dr. Moon. We're about ready to roll on a high-speed shot.
Oh, that's great. Mr. Margosian is one of our skilled technicians here at Moody Institute of Science. In addition to a rich background of photographic experience, he's shown a more than usual interest in the subject of time. Pete, do you suppose you could tell us just a bit about the equipment that you use?
I'd be glad to. The most important piece of equipment is right here. It's a super high-speed camera. I like to call it a time microscope. It does to time what the microscope does to physical dimension. It enlarges a period of time instead of a bit of matter.
How fast will the camera be running on this tape, Pete?
About 3,000 frames per second.
Let's see. That'll stretch 1 second into about 2 minutes, won't it?
Yes, 2 minutes and 5 seconds to be exact. And this will give us an opportunity to observe some interesting properties in liquids. We're using milk in this experiment because it photographs easily. I'll adjust the flow until it appears a fine trickle to the eye. There. Would you start the camera, Doctor?
Now?
Ready?
The trickle of milk and the splash look quite different now, don't they? But they aren't any different. The liquid is behaving in its usual manner. We've merely changed our time reference. Did you ever drop a steel ball into a bowl of milk? There's probably no good reason why you should have, but it does make an interesting high-speed study. Watch. The high-speed camera checks the ball, and the steel ball seems to float slowly downward to disappear beneath the surface of the liquid. Then, when you've almost forgotten about it, the ball slowly bounces back. Don't be confused now. This isn't one of the ghosts we were talking about. It's just the milk that follows the ball into the air. To never question what appears to be normal is one sure way of staying locked up in your time compartment. To study time, we must venture beyond the ordinary. And when we do, it opens up a whole new realm. Pete, would you help me with an experiment?
Surely.
Just take the egg and stand right over there. That's fine. Now, will you balance the egg on your head, please?
Hey, wait a minute. If you have in mind what I think you do, no thanks. But I'll be happy to set it up over here for you.
Well, maybe that would be safer, Pete. You know, if William Tell had been in the chicken business instead of the apple business, the story might have gone something like this. Of course, the flight of that arrow required but a tiny fraction of a second. But the high-speed camera slowed it down until we could study the entire action. Recently at the University of California at Los Angeles, a high-speed camera study was made of that split second involved in a head-on autocrash. That's what happens when we crack up at only 28 miles an hour. Not many of us keep it down to that anymore, do we? It's a bit disconcerting to realize that just a fleeting moment of this stuff we call time can introduce you to a whole eternity. The high-speed camera tells us part of the story of time. But strangely enough, the time compressor will show us even more. The time-lapse camera, or the time compressor, is just the opposite of a high-speed camera. Instead of slowing things down, it speeds them up. The world about us is alive with action and movement that we miss because it's too slow. There's a veritable symphony of movement that we never see because we're locked up in our own little time compartment. The time compressor can help us break out of our time prison. Here's a good example of movement that we can't see. Let's set the clock now for 11 o'clock. Right, the clock is running. The hands are moving all the time. You can't see them move. Oh, if you watched long enough, you could tell that they had moved, but you can't see the movement. That is, not unless we use the time compressor. Did it seem to you that the hands of the clock speeded up and slowed down? Well, actually, they didn't change speed at all. The clock kept right on running at standard clock speed. You've been watching it for a whole day. Now, we just changed your time reference by changing the interval like this. Every time the lights go on, the camera takes one picture. If you're still not convinced about that clock, maybe this will help. That isn't a magician's rose. It's a flower right out of the garden. This time, you watch the clock and the rose. We are now taking pictures at a 10-minute interval. Of course, we're projecting them at standard sound speed. This means that we are compressing 72 hours into just 18 seconds. Yes, this is a real rose. And these are real whiskers, too. You see, I haven't shaved since you started to watch that rosebud open 3 days and nights ago. Gives you something to think about, doesn't it? This is a 3-foot length of standard 16-millimeter motion picture film. On it, there are 120 separate pictures. This 3 feet of film could go through the high-speed camera in a... Oh, I shaved while you were looking at the close-up of the film. You see, we used the time-lapse camera to take the close-up, so there was plenty of time. This 3 feet of film could go through the high-speed camera in 1,000th of a second. The same length of film in the time-lapse camera could take days, months, or even years to expose, according to the interval that we used between exposures. I suppose that we could call a piece of film like this a memory with a variable time reference. Say, would you like to take a nice 2-day vacation? All right, sit back, relax, and enjoy yourself.